Hi, Earth and Space. So today we are going to continue on with a little bit of our notes that we did not finish up from yesterday. And then you'll have some review questions to work on as well. So make sure you copy these notes down into your Notability file. So you either have to dual screen this video with your Notability screen, or you can watch this video on your phone or something else. So yesterday we had talked about the three different kinds sorry, here I'm going through there. The three main layers based on composition. We have the three layers, which are going to be crust, mantle, and core. And we had just talked about crust yesterday. So crust is the part of the Earth here, the most outermost layer of Earth. It makes up less than 1% of the Earth, but it's the part that we're most familiar with. We do have two different types of crust, oceanic crust and continental. Oceanic crust we can look at this table here of differences, and you can see that oceanic crust is very thin, and very dense, but compacted with a lot of different dense, heavy minerals, and basalt is our main rock from there. And continental is very thick compared to that, but less dense and made up of lighter minerals in the scheme of things. So granite's the most common rock, but all types of rock are found in the continental crust, all sedimentary rocks and other igneous rocks and things like that. So now we talked about the mantle and the core as well. So the mantle is that middle portion of the Earth, and the core is that center portion of the Earth. So as far as composition goes, the mantle is made up of really hot, very ultramafic, so like even more dense rock than the crust is. Because things that are more dense will sink or be drawn to the bottom, and so that's why we can say that the mantle is made up of denser rock than even the crust is. Then the core is made up of extremely dense materials, iron and nickel, which are both magnetic as well. So now we can talk about how we can divide the Earth's layers by properties. So when we do it by properties, we actually have 5 different properties, or 5 different layers really, that we kind of look at. So it's the same, we're talking about the same, structures. It's just that we divide them a little bit differently, and parts of the crust and things are included, or the mantle's included in several different ones. So we'll start at the very top and work our way down. That's usually how we do it. So the lithosphere is composed of all of the crust, so it contains all the crust, and a little bit of the upper part of the mantle. So the very, very top of the mantle composes the lithosphere. So if we look at this picture down here, I can see continental crust here in light gray. I can see oceanic crust here in orange. And I can see the lithosphere is marked with this red arrow, and it includes a little bit of this area here in the lighter gray. Now, if I look at this blue arrow, it tells me that all of that light gray, and then these kind of 2 shades of pink are all part of the upper mantle. So again, the lithosphere includes all of the crust and then the upper part of the mantle, usually down to about 100 kilometers or so. It's about 60 some miles. So remember we're dividing this by properties. So what's special about it? What is, a property is what is a characteristic about it. So the lithosphere is very rigid, which means it's strong but yet breakable, if that kind of makes sense. Rigid meaning more solid, I guess we should say, but brittle meaning that it does have cracks and bends and breaks in it, and it can be kind of maneuvered. And we'll talk about that more as we get into plate tectonics, because that's the reason that we have them. The asthenosphere, so that's how we say that, asthenosphere, is partially molten, which means melted, upper mantle. So again, still part of the mantle, the upper mantle we say, and that is this piece right here. So it lies just below the lithosphere, has more of a plastic type of property to it. So it's not completely rigid and solid. It can kind of flow very, very slowly. It's definitely not liquid, but I kind of compare it to more like kind of like clay almost. So something that's, malleable and movable, but generally still pretty solid. Okay. And like plastic, you can kind of bend it and move it, but it can flow very slowly. So these two characteristics are super important. These two properties are very important in understanding how the inside of our earth works. So just remember these as we go. So as we continue down, then we get to the last part of the mantle. So we kind of talked about the upper mantle. The lower mantle is really like the lower 2/3 of the mantle. And basically rock here just gets, temperatures just continue to increase. Rock is still solid, but as you keep going down and down and down, it becomes more and more malleable and softer. So rock gets more fluid. Again, not completely liquid yet though. And then convection currents are an important role here within the mantle and within the asthenosphere. So convection currents are caused by the heating and then the lack of heating of rocks. And so we have this kind of cycle that continues to go. And so if we look here in this picture, you have this outer core and inner core. Both of these are extremely hot. They're the hottest parts of our planet here, upwards of thousands of degrees. And the outer core, as we'll get to see here in a little bit, is liquid. All right. So we have liquid, hot, molten rock. And what happens is that it heats this solid-ish rock right above it in the mantle. When things get heated, the molecules spread apart and they rise. Warm air rises. You probably have heard that statement before, or that saying before. And that's because the molecules spread out and they become less dense, and things that are less dense rise. So the very, very hot rock rises up to the top of the mantle. And you can see here it gets to the asthenosphere. Now at this point, the rock is still hot, but it's a lot cooler than it was down here, right? So it's cooler up here than it is down here. Now it's still, hundreds, of degrees, maybe 1,000 degrees or so, but it's definitely a lot big of difference between like 6,000 degrees and 1,000 degrees. And so as it becomes cooler, it starts to condense again, which means it kind of comes back together, and it becomes more dense as it moves across here, and then it gets to a point where it becomes too dense, and then it sinks. And things that are more dense sink, and then it kind of comes back down here and starts all over again. So this process of convection currents occurs here within the mantle and a few different other places on Earth. So I always kind of compare it to a lava lamp. If you've ever had one at home or something similar to that, the lamp is being, or you have a ball of wax at the bottom, and you have a light bulb that's in the inside, and that is the source for your heat. Okay, so the light bulb will be like right here where you have the inner and outer core. And as it gets heated, as the light bulb gets warmer and warmer, it warms up that wax, and that wax will start to get less dense and spread out a little bit. The molecules will, and they'll rise to the top of the lava lamp, and you'll get this big bubble that goes up. And then as time goes by, if you watch that blob up at the top, eventually it will, since it's away from the heat, it becomes a little bit denser, sinks, comes back down, and repeats the process. All right, so then the outer core, as we mentioned already, is made of a very dense liquid metal. And we already talked about how we kind of know that at least the outer core is liquid because S waves can't go through that. But the hot temperature down there just causes rock to completely melt, no matter what the minerals are. So everything melts in there. And then we get to the inner core. And the inner core, you would think, well, that's probably liquid too, right? Because it's even hotter, which it is hotter. However, the liquid core is actually made up of very, again, even more dense, solid metals. So how is it solid if it's that hot? Well, at this point, the pressure from millions of tons of earth and rock above it is too much to overcome, and it can't even move out of its solid form to heat up. and to move around. So at that point, the pressure kind of overtakes the kinetic energy of those molecules that causes them to move. So they stay in a solid form. All right, so then for your assignment, the rest of your assignment here is to answer these review questions. Make sure that you read and answer all parts of the question. So for this one, you have to list and explain 2 ways that scientists have learned about Earth's interior. So make sure you list and then explain. Number 2, what layers of the Earth are divided in? What layers is Earth divided based on composition and based on properties? So again, how is it divided on composition? What are the layers based on properties? I want you to list 3 different ways that the oceanic crust is different from the continental crust, and then explain the difference between the lithosphere and the asthenosphere. So you can kind of describe both there. And then where do convection currents occur, and explain what happens in them. So tell me where they occur, and then I also want you to explain what happens. You might need some more space for that one. And then 6, explain the differences in the outer and inner core. We just talked about those. All right, you will just need to send me screenshots of these review pages from the review slides here. I think looks like it's 16, so 14, 15, and 16.